Hello everybody, get ready to do lesson 3.2 part 1 pre-calculus math today. If you need quizzes, tests, note-taking guides, videos, email me here for that course material there. 3.2 part 1 logarithmic functions and their graphs. You got a 58-point classwork lecture. Note-taking guides I do have for this, so contact me for those. And then teachers, we go into a bell work today. Here is today's bell work. Determine whether the function has an inverse function. If it does, find f to the negative 1, f of negative 1 of this function here. What would be the inverse of that? What would be the inverse of that? Give your students 5-6 minutes for that. Welcome back for solutions for today's bell work, finding inverse functions. So to find f of negative 1 for number 1 up here, f has an inverse because f is 1 to 1. So we have a 1 to 1 relationship here. And then we go into, we change positions now to find our inverse. F of x is y equals cube root of x plus 8. Now we switch variables here. Y becomes x becomes y. And we take the cube root now of this and we solve for y. So then we take the cube root of both sides. X cubed equals y plus 8. Then y equals x cubed minus 8. So f of negative 1 of x equals x cubed minus 8. That's your inverse function for this function up here. And then down here, f is not 1 to 1 because we have a square inside our radical, so it does not have an inverse function for this case. Okay, into our lesson today, logarithmic functions, page 1. When a function is 1 to 1, the function has a property that no horizontal line intersects its graph more than once. By looking back at the graphs of the exponential functions, you will see that every function of the form f of x equals a to the x, a greater than 0, and a cannot equal 1, is 1 to 1, passes a horizontal line test. Remember the vertical line test? That was for a function. Well, 1-to-1 relationships are determined by the horizontal line test, and therefore must have an inverse. If it passes a horizontal line test, therefore the function will have an inverse of itself. This inverse function is called the inverse function with base a. So for an exponential that passes to 1 to 1, the inverse will be a logarithmic function with base a. Definition of a logarithmic function for x greater than 0, and then a greater than 0, a cannot equal 1. Y equals log base a x if and only if x equals a to the y power. The function given by f of x equals log base a x, read as log base a of x, log base a of x, is called a logarithmic function with base a. So this is on your classwork sheet. Take notes of this, or if you get a note-taking guide, this will be included in your note-taking guide. Every logarithmic equation can be written in an equivalent exponential form. Every exponential equation can be written in logarithmic form. The equations y equals log base a x and x equals a to the y power are equivalent. So these are different forms of the same thing here. When evaluating logarithms, remember that a logarithm is an exponent. This means that log base a of x is the exponent to which a must be raised to obtain x. So for log base 2 of 8 equals 3, because 2 must be raised to the third power to get 8. So it's just another way of expressing an exponential expression. Okay, let's go into an example here. Evaluating logarithms. Use the definition of a logarithmic function to evaluate each logarithm at the indicated value of x. So f of x equals log base 2 of x. And then in this case, we're going to throw in 32 for x. So f of 32 up here, f of 32 equals log base 2 of 32 would equal 5, because 2 to what power equals 32? It will be 5. So that's why this up here would equal 5. F of x equals log base 3 of x when x equals 1. So in this case here, f of 1 equals log base 3 of 1 equals 0, because 3 to the 0 power equals 1. And then f of x equals log base 4 of x. And then when x equals 2, f of 2 would equal log base 4 of 2 would equal 1/2, because 4 to the 1/2 power, or otherwise the square root of 4, would equal 2. And then f of x equals log base 10 of x. And then in this case, we're going to say x is 1 over 100. So f of 100 would equal log base 10 of 100 would equal -2, because 10 to -2 power would be 1 over 10 squared, which would be 1 over 100. Into our first guided practice here, use the definition of a log function to evaluate the function at the indicated value of x without using a calculator. So for number 1 up here, our first guided practice, f of x equals log base 2 of x, and in this case x would equal 16. So 2 to what power, basically the question is 2 to what power would equal 16. So to solve that, log base 2 of 16 would equal log base 2 of 2 to the 4th would equal 4. So 2 to the 4th power, these would cancel here, log base 2 of 2, these would cancel and your 4 would drop down, so it would equal 4. So 2 to the 4th power would equal 16. This is your independent practice here. Okay, this goes into your notebook. The logarithmic function with base 10 is called a common logarithmic function. On most calculators, this function is just denoted by log. So on your log button, that would be how you would calculate common logs. So let's do an example of those, evaluating common logs on a calculator. So use a calculator to evaluate f of x equals log base 10 of x at each value of x. So for this, when x equals 10, so log base 10 of 10, log base 10 of 10 would log 10 enter, that would equal 1, so 10 to the 1 power would equal 10. And then when x equals 2.5, so f of 2.5 would equal log base 10 of 2.5, log 2.5 enter, that would be how you would enter it into your calculator. That would equal this number here, 0.3979400. And then when x equals -2, so f of -2, log base 10 of -2, log -2 enter, that would be an error because you cannot take a log of a negative number. Cannot do it. No logs contain a negative number. Okay, when x equals 1 over 4, so f of 1/4 equals log base 10 1/4. So we're going to use parentheses here, log, open parentheses, 1 divided by 4, close parentheses, and hit enter, and we get this negative number here. If it's less than 1, then we get a negative result. If it's a negative, that you're trying to take a log of a negative number, it won't work. You'll get an error message. Okay, into our next guided practice. Use a calculator to evaluate the function at the indicated value of x. round your result to 3 decimal places. So for our first one here, f of x equals log base 10x when x equals 345. So then down here, this is your independent practice here. So with this one here, log base 10 345 would equal 2.538. So 10 to the 2.538 would equal this number. And another notebook entry here, page 11 on our lecture today. Properties of logarithms. Log base a of 1 equals 0 because a to the 0 would equal 1. And then log base a of a equals 1 because a to the first power would equal a. And then log base a of a to the x equals x. And a log base a to the x would equal x. So we have inverse properties here. Basically, a to the x would equal a to the x. And then when you put this up into your exponent here, these cancel. Your a log a would drop this down. This would be 1. A to the log a power would equal 1. So then we just have 1 times x would equal x. Then for log base a x equals log base a y, then in that case it would be x would equal y in this situation here. Because the only thing different, they're both to the same base, and then x would be what you're taking a log of, and then y would be what you're taking a log of here as well. If they equal each other, then x would equal y. One-to-one property there, using the horizontal line test. Okay, into our next example here. So example 3, using properties of logs, solve for x. Log base 2 of x equals log base 2 of 3. So using the one-to-one property, property 4, you can conclude that x would equal 3 in this case here. They both have the same base, so x would have to equal 3 here. I mean, what you could do is you could divide this side by log base 2 and divide this side by log base 2, and you get x equals 3. And then solve for x here. Log base 4 of 4 equals x, so what would x equal in that case? Using property 2, you can conclude that x equals 1, so 4 to the x power would equal 4, so x would have to equal 1 for that. And then C, simplify log base 5 of 5 to the x power. Using the inverse property, property 3, it follows that log base 5 of 5 to the x power would equal x here in this case. So log base 5 to the 5x power would equal x in that case. 5 to the 5x power would equal x. And then simplify 7 to the log base 7, 14. These are going to drop down here. Using the inverse property again here, property 3, it follows that 7 to the log base 7, 14 would equal 14. These would cancel each other out here, and it would drop down, and it would be 14 would be what this situation up here would simplify to. And same thing up here, this would drop down and it would just equal x. These would basically cancel each other out. Okay, into our next guided practice. Solve the equation for x. Log base 7x equals log base 7, 9. And then this is your independent practice here. So let's do our guided practice up here. X would equal 9 here, because we could divide both sides by log base 7. That'd be the algebraic way of doing it. And then x would equal 9. Then here I'm going to let you do that. Notebook entry again, page 14 on your lecture. Graphs of logarithmic functions. To sketch the graph of y equals log base a of x, you can use the fact that the graphs of inverse functions are reflections of each other in the line y equals x. A good note here to put into your notebook. So let's do one of these. The graphs of exponential and logarithmic functions. Same coordinate plane, sketch the graph of each function by hand. So we have f of x equals 2 to the x. So f of x equals 2 to the x, construct a table of values for that. And you should bring this up on your calculator, or if you want to, you can do it by hand. So start here, x equals 0, y equals 1. When x equals 1, y equals 2. When x equals negative 1, y would equal 1/2. By plotting these points and connecting them with a smooth curve, you get something like this here. Here's what you'll get for f of x equals 2 to the x power. This is what your graph should look like here. And then here are your plot points here. This is key, and then this is key. That's these 3 points here. And then g of x equals log base 2 of x. So what would that look like? Well, g of x equals log base 2 of x is the inverse function of f of x equals 2 to the x. This is the inverse of that. The graph of g is obtained by plotting points f of x and x and connecting them with a smooth curve. The graph of g is a reflection of the graph of f in the line y equals x. So y equals x would be this line here. This is y equals x. This is f of x equals 2 to the x power. And then this is g of x, which is log base 2 of x. So these two are inverses of each other. 2 of x and log base 2 of x. And you get this situation here. This is your line y equals x. This is a reflection of that. And that's how you get this line here. Okay, sketch the graph of f. Here's our f. And then use the graph of f to sketch the graph of g. Here's our inverse of this up here. Same thing down here for your independent practice. So what are these graphs going to look like? Okay, f of x equals 3 to the x and g of x equals log base 3 of x are inverse functions of each other. And then this would be the how they would look. Here's your y equals x, goes through your origin like this. It would be like a direct variation kind of line here that goes through the origin. And then 3 of x would be this function here. This would be f. And then this is your g here. So this would be a reflection of that. And that's your 3.2 part 1, pre-calculus. If you need note-taking guides or tutoring or other worksheets, contact me at this email. Thank you very much.